Excellent. Let's welcome Suz. Thank you. Hey, thank you for coming back so promptly from lunch. That's awesome. So my talk is called Babbling with Merfolk. So you may be like, what does that have to do with JavaScript hardware? But it's okay. I'm going to explain what that is. And I sort of want to go a couple of layers deeper than just JavaScript. So we're going to start with that, and then we're going to go a little bit deeper. So Merfolk, yeah. So the importance of abstraction is something that I want to talk to everybody about. So this in particular applies to people who are writing JavaScript libraries and trying to keep in mind your users. The baked-in empathy and beauty of JavaScript hardware compared to other languages that have implemented hardware libraries. I also want to take you on a bit of a technical deep dive of the Arduino platform. Now, don't be afraid of that because I've come up with a fun adventure that we're going to go on together in order to discover how that works. So this is what you can expect from the talk today. About me a little bit. My name is Suz Hinton. You can follow me on GitHub and Twitter and almost everywhere else at NoobCat. It's technically NoOpCat, so yep, that's where that comes from. I currently live in New York City in the USA. I'm a front-end developer at Kickstarter, which is really fun. I really like robots, so that's kind of why I'm up here talking to you about them today. So this is a small sample of the things I've backed on Kickstarter. It helps that I work there. I basically have an empty wallet. My paycheck just goes straight back into Kickstarter at the end of the month. I keep looking at my statement, and there's all these random Kickstarter pledges being collected. But this is the technology. This is filtered by technology. And as you can see, maybe not those at the back, but at the front, there's kind of a recurring theme through all of this, right? And that's that I've been mostly funding microcontrollers. I have a bit of an issue. I was too embarrassed to share a photo of all of the microcontrollers that I currently own. But this is an example of a microcontroller, and we're going to be looking at this one in particular today. But for right now, all you need to know is they allow you to control things like sensors and motors and all sorts of really cool stuff without needing to be an electrical engineer. This is an example of a project that I did a while ago. It's called meowshoes for obvious reasons. There are some pressure sensors in the heels and toes of them. And basically, it can act as either a game controller or a musical sort of synthesizer. So I wrote a really quick browser app that allows you to, it has a metronome and you can sync up musical beats with different kind of instruments and things like that. So definitely check that out on my GitHub. It's meowshoes. If you'd like to make them, there's actually a book, I forgot to put the slide in, called JavaScript Robotics. It just came out. It's by Make Magazine, O'Reilly Media, so definitely look that up. Mine is chapter 14. You can totally make these from scratch. So this is called the PUR. It's the Personal Ultimate Reassurance Response. I made it for a hackathon, and this was with a smaller Arduino. And what it does is it measures your heartbeat and sort of, monitors your pulse. And so I have an anxiety disorder, and so I kind of made this for myself and others that go through the same thing. And so when you've got a very high heart rate for a sustained period of time, it will start texting you pictures of kittens to help calm you down. I thought it was a good idea at the time. I think it was for an AT&T hackathon, which is an American telephone company. Recently, I wrote some JavaScript hardware to power these screens here. There's not really many JavaScript sort of libraries out there that can drive these things. So it's called OLED.js. And if you're sticking around for Node One Shot tomorrow, you'll actually hear me talk about what it was like to write this library and some tips and stories from the trenches. So that was actually really fun, being able to get right down to the bits and bytes of a device, which I'll talk about a little bit. So how do I make these weird, crazy contraptions? Obviously, I'm using a microcontroller because that's what we're talking about today. The Arduino Uno is a really popular one because it's cheap and it has a lot of kind of features that you can use, and it's the documentation for it is readily available. I use a Node.js library called JohnnyFive. Has anyone heard of this? Yeah, cool. Okay. Yeah, awesome. JohnnyFive just allows you to treat the Arduino like an API. So anything you plug into it, you can instantiate a new version of, which I'll show you later on. So it's really easy to use, and the focus for my talk today is about how beautiful the API is and what we can learn from that. So just wanted to warn you all, and yeah, shout out to Matthias, I have some Unicodes in here and I'm not escaping them. This is not a guide on how to get started with JohnnyFive. There's actually some really good documentation out there. And on top of that, there's some really good speakers who have introduced it who could do a way better job than I could. So the website for that is johnny-five.io, and yeah, super awesome website. I actually stole a GIF from it, so thank you, Recordrien. I want to talk to you guys about abstraction and what that actually is for JohnnyFive and how that enables a lot of people to do things when they don't have to know what's going on underneath. And so right now there's more than 700 programming languages out there, right? And that's just the notable ones. And abstraction kind of is the reason why we get anything done all day. Like, no one writes in machine code because we'd never get stuff done. It's just so manual and long and error-prone. And so actually having programming languages is a big reason why we enjoy programming so much, right? And so why would you do hardware with JavaScript? You know, like, JavaScript is in the browser. It just doesn't make any sense. And actually, I was telling a colleague that I was doing this talk just a few days ago, and he sort of said to me, like, why JavaScript? And actually, the same day, Cassandra Perch, who was a friend of mine, tweeted, when I have to drop back into non-JavaScript robot code, I'm constantly reminded of why I love JavaScript for robots. And that's the event emitter, plain and simple. So what she's getting at here is that sometimes you want to control robots in an asynchronous sense, you know, because you want it to be reading sensor data and then reacting to it and that kind of thing. And so it's actually really ideal for that. And there's some other reasons why JavaScript is so good for this, which I'll go over soon. Way better than my answer, because when they asked me at the time, I was like, because browser, you know, can do things in and outside the browser. And that's a perfectly valid reason too, but not as impressive. Another reason why it's so good is that the JavaScript scene has kind of exploded with this modular kind of way of doing things, which CJ touched on earlier. With Node.js, you know, you can install all these packages from NPM, and they're all self-contained, and they do very specific things. And so what Node.js has given us is the ability to stop writing so much scaffolding and actually start coding really expressively. And I've been super inspired by that, and it's a big reason why I love JavaScript so much, is that we do a lot of heavy lifting for each other, and we support each other in that way. And JohnnyFive is actually no different to that, so I wanted to look at the API of it. So nowadays with JavaScript, and I've checked out other kind of popular languages, and there's just not as good of an implementation of this. It is sort of possible, this is pseudocode, but it is kind of possible to just say, well, I want my robot to do a cool thing. And I think that's actually really beautiful and expressive, and it just allows people to concentrate on the fun stuff. The other side of that, though, is when we allow these modules, you know, these self-contained things to do a lot of work for us, we don't always get to find out, like, why or how they work. And I remember as a young child, that was my favorite question, was why. I'm sure it was everyone's favorite question. But we stop asking that, you know, and I think it's really good to be able to peel back the layers and have a look at what's actually going on beyond the abstraction. So we're kind of going on two sides of this today. But I want to take you for a peek underneath what actually happens when you have to interface with hardware with JavaScript, because it's a lot of layers like an onion. So where am I taking you guys today? Well, let's say that this here, you know, you're sailing on the ocean, and this is kind of your API level. You're outside of the node modules directory of your project, and you're just sort of writing expressively, and you're using JohnnyFive, or you're using underscore or something like that, and everything's just so beautiful. You know, you can really appreciate the ocean because you know it's keeping you afloat, but you sort of can't see under the surface, and so that's a perfectly beautiful place to be, and you should definitely feel like you can always stay above that level. I'm going to be taking you down here for a little bit. This is sort of where you start taking a deep dive and you actually start seeing your ecosystem for the first time, and you think, wow, there's like fish down here, and there's all sorts of stuff working together in order for, the boat at the top to actually float. This is a living organism. So we're going to stay around this level for my talk. This is kind of the crazy level where there's a mermaid and she's speaking binary to you and you have absolutely no idea what she's saying. We're going to touch on this a little bit, but we're mostly going to, sort of stay up on this level, yeah. I think we're going to be okay. So let's begin. So usually when you start a new programming language, the first thing you want to do is obviously have it print hello world on the screen. But do you see a screen on this Arduino here? Not really, right? And you can't always guarantee you'll have a screen with hardware. And so the hello world of the Arduino land, I guess, is blinking an LED light on and off. So you can see there, this is the GIF I ripped off from the JohnnyFive website. This is actually our hello world. So this is the example I want to show you today because something as unassuming as hello world can actually be so much more complex than what you would think. So these are the lines of code required to do that hello world. Of course, we're in Node land, so we are requiring the JohnnyFive library. Then we're instantiating a new board. And what's the board, you probably are asking? Well, the board is the Arduino microcontroller board itself. So we're instantiating a new instance. And underneath that, it's polling the USB ports and trying to find where it's plugged in. Once that board has, reported back that it's ready and that it's been found, we're then going to instantiate a new LED, which is the light that I had plugged into pin 13 on the previous slide. And so we pass in the pin number so that it knows, where to find that. And Bob's your uncle, you've got your LED. And so the line that I want to talk about is this one here. This is essentially our hello world. It's led.blink. Now you probably can guess what the number there, the integer that's put in between the parentheses. It's the amount of milliseconds between turning the light on and turning the light off, right? Pretty straightforward. But, this is something very beautiful because you're just saying blink the LED and then it goes through the USB cable and it's just working. Like that to me is an incredible abstraction, and I think that Rick Walden and the other contributors to the JohnnyFive library should be very proud of that. So we've got LED blink. Let's go a level deeper. This is something we can all kind of understand, right? So this is JavaScript again, and it's just setting an interval. And so there's nothing fancy about that. We've got our rate that we passed in, as our milliseconds. This is referring to our LED instance itself. Now, you're probably thinking, well, toggle is not a native JavaScript method. It's not. And so, what is toggle doing? And you can probably guess, right? You can see where we're going. So if we go a little bit deeper again, I've just pulled out the main guts of the code. We're setting this dot value to 255 to turn it on. And again, this is our LED. And then we're saying this dot write. And then to turn it off, we do this dot value, set it to 0, and then we're then writing that value. So the first line is pretty straightforward, right? You're thinking, well, that's brightness. 255 is like very well known as a maximum value that you can write if you were to be thinking about bytes and things like that. And 0 is pretty obvious. We want nothing. We don't want that to be on. But what is write doing? Like, what is that? That seems like it's just writing and it's magic. What's going on underneath that? Well, to find out, we kind of want to cross over to the other side because we've got our laptop and the Arduino is plugged into it, but they don't really speak the same language, right? One's this amazing multi-core computer and the other one is just got a very simple chip on it. So how do they actually talk to each other? Like when it goes from JavaScript, pretty sure the Arduino doesn't understand JavaScript itself, unless you're using a Tesla or something that can actually run it. So let's have a look at this. For those who haven't seen an Arduino up close before, we have these pins running along the top and the bottom. And those pins are just holes and contacts that you can plug sensors and motors into to control them. And most of the pins are numbered. We have some digital ones and some analog ones. And so the numbers are really useful because obviously you want to be able to reference specific things plugged into the device. But we have these connections that go from each pin. For example, these are all of the analog pins. They all go into this long kind of dark thing that's just sitting in the middle of the board. Now that's actually the brain of the Arduino. That is the ATmega 328P. It is a chip, essentially, that allows you to control those pins. So the chip is able to read from pins if it's a sensor, and it's also able to write to a pin if you've got something like an LED or a motor plugged in. Now, if I was to draw all the traces that go, into this chip, for the other pins, it would look like a dog's breakfast, and it wouldn't really illustrate very much. But all of those are also plugged into the chip itself, too. And this here is pin 13. And the reason why pin 13 is used a lot is it's right next to a ground pin, which is really useful when you're plugging an LED in. It's also one of the only pins that has a resistor sort of soldered between the chip and it. And the resistor essentially stops you blowing up your LEDs because they actually take a pretty low voltage. So there's a bit of trivia for you as to why we choose pin 13 for a lot of our Hello Worlds. And so, all the traces, all the wires are actually going into the chip at all these contact points. So if you look on the back of an Arduino, you can see those soldering joints there. But what's happening inside the chip? Like, how is it actually controlling this? And how do we get back to this write function that we were talking about? Well, this is where we're going to go on a little adventure, and I want you to think about the ATmega 328P as an office building. And there's a lot of flurry of activity happening inside, and there's lots of different kind of sub-offices as well that are controlling a bunch of things. So let's have a look inside and just take a brief look at what we're probably going to see. We have this concept called registers, and I want you to think of these registers as offices. So they all have a specific concern. There's quite a few registers. We're going to be looking at 12 of them today. And these offices are responsible for doing one function and one function only. And there's 3 office types we're looking at today. One is called DDR, one is called pin, and one is called port. Now, if that doesn't make sense, that's okay. We're going to get to that. So 3 office types, and they're actually the registers that help to control the pins. Bit of a spoiler alert there. So of those 3 office types, DDR, port, and pin, we actually have 4 of each office. And the reason for that is we have so many pins, we need enough offices to be able to deal with them all. And so every pin has its own reference in an office, as you'll see soon. So for example, for port, we have port A, port B, port C, and port D. We have pin A, pin B, pin C, pin D, and we also have DDR-A through to D as well. Now, the most important thing you should take away from this is that an office actually more or less is concerned with 1 byte. So we just have like 1 byte of data there, and I'll talk to you about what that actually does. Now, DDR, you might be thinking there's this crazy Dance Dance Revolution party going on in the office, right? Well, unfortunately, it's not as fun as that. DDR stands for Data Direction Register. So this office here is concerned with, is the pin that I'm supposed to be talking to an input or is it an output? This is where you can actually set it. So if you plug a sensor into your Arduino, you want that to be an input, right? You want to be able to read from it. And if you plug something like a motor or a light into your Arduino, then you want that to be an output because you're trying to like write a value to it. You're trying to tell it to do something. The port office is actually concerned with the latter there. So the port office is only concerned about writing values to pins. It's not reading, it's just accessing the right pins and writing the values that you request. And then we've got pin, which is confusing. It's like that PHP recursive thing. Someone thought it was funny to do this. The pin offices are concerned with reading a value from a pin. But we're probably not going to be talking very much about that today. And so, like, what is actually really happening in these offices? Like, what makes them control these pins? Well, I bet you didn't think that there were cats inside your Arduino, but there actually are. I'm sorry to tell you, it's happening. So this is the DDR-B office. So this is where we're setting the data direction. Is the pin an input or an output? Now, why are we in DDR-B? That's because this is where you can actually control pin 13 and tell it which direction. Is it an input or is it an output? And if you count how many switches there are on the wall there, how many are there? There are 8, right? And so this is a byte. This is your representation of a byte. Now, every pin in all of the every pin has a bit reference in one of the DDR offices. So this happens to be DDR-B for pin 13. And what happens is if we want to set that pin to an input, then we have that bit in the off position or set to 0, right? But if we actually want to write to it, which we do in this case, we want to turn that LED on, we need to actually switch that bit to 1. And so the job of this kitty here in the office is to go and switch that to the 1. So now that we've done that, right, our pin is actually ready to be an output. That's as simple as it was. That's how it works in our microchip. That's what sets it in the register. So we're done with that. Thank you very much, kitty. Okay, so we have port B office. We have this lovely chocolate brown kitty. And this kitty here he's concerned about writing to this pin, right? Because it's port, pin is reading, port is writing. And conveniently, pin 13 is also the 6th bit in this byte in this office in B as well. So it's a very well-designed system. You know, it's not too confusing. It works out really well. So this kitty, if we want to actually write the maximum value to that pin, we want to switch that switch on, right? And if we want to write like a 0 or a nothing, then we want to turn that switch off. Now, the reason why I've chosen switches is because this is actually dealing with electrical current, right? As soon as you flick this bit here, we're going to have electrical current flowing through the pin, and that's what turns the light on. Now, our hello world was a blink, right? So you can imagine what this kitty has to do. Every 500 milliseconds, he's got to flip it on, he's got to flip it off. He's got to flip it on, he's got to flip it off. So I feel really bad for him when it's a blink, you know, because he doesn't get to have a coffee break or lunch. You know, he's just got to keep doing it till you're good. And then another one we won't talk about today is the pin. This kitty here is responsible for setting whether or not we're reading from the pin or not. And so again, conveniently, it is the 6th bit. And although I didn't write the letter there, it's actually in the pin B office. So every pin has a reference bit in the 3 different offices, and that's kind of how we change the mode and we read and write to it. That's how the data actually flows from the pin to the chip and then out to the computer. So here's the collection of all the offices there, just to drive the point home. We have DDR A to D, port A to D, and pin A to D. And so all of these sub-offices are sitting and waiting in the register, the AT mega. And there's other registers or offices too that deal with different things, but these are the ones that influence the pins. But surely these cats are kind of just isolated in their office, and they don't really know when to flip the bits. And this hasn't really answered our question of how does the computer tell the Arduino to do that? So in order to do that, we need to introduce a new responsibility. And it's a very high responsibility. It's very prestigious. And the answer to that is Fermata. Now, Fermata is a library that you upload to your Arduino. And essentially what it does is it turns it into an API. And so it allows you to communicate over USB. But what is it actually doing? Well, this is Fermata. She's definitely Fermata. She's got a name tag telling her so. And what is she doing? Well, she's sitting there and she's watching all of the data coming in, and that's what's scrolling there. And she's also looking at all of the pins and their values that they're returning, and that's on the left there. And she's kind of poised and waiting. She's waiting for a request to come in from our laptop and our USB connection, and she's super ready to tell those kitties what to do. So she's like the boss crocodile. So what she does is, in our Hello World instance, I apologize for these slides. she calls our DDR kitty, that's the gray kitty, right? And she says, hey, calling the DDRB office, this is for pin 13, right? And the kitty's like, yeah, this is for pin 13, it's the 6-bit. She's like, I'm going to need you to switch that to the 1 position because we want to write to that pin. And the kitty's like, cool, all right, gotcha, done. And the crocodile Fermata is, thank you very much. She then gets back on the phone and she calls the port office, and it's port B, as we know, and she's like, this is for pin 13, right? And he's like, yeah, it's the 6-bit, you got this. And she's like, can you just switch it to the on position, please? And it's like, yeah, cool, I can do that. And then she switches it, she's like, thanks, and she hangs up. And then she picks up again, because she's had another request through, and she's like, I need you to turn that off again. He's like, oh, okay, I just turned it on. And so this goes forever when you're blinking. So I want you to feel really guilty when you're blinking a light, because this stuff is going on constantly in the background. And so, we come back to our write, right? So our Fermata crocodile, she's ready for that write request to come in. But we're sort of missing a piece. Surely JavaScript is not actually telling the Arduino to do that. Well, this is kind of where we are right now. We have the phone call going on. We have JohnnyFive on the left. But there's some missing pieces. So what are the other pieces? Well, believe it or not, there's actually a Fermata port for JavaScript. It's written in Node.js, and it's called Fermata.js. Now, I want you to think about this second crocodile as like an interpreter. So Fermata.js can take what JohnnyFive wants to do, and it can assemble the correct bytes. It speaks the same language as the Fermata crocodile on the Arduino. And it can say, okay, I know what you want to do, so I'm just going to tell them to do that. You don't have to worry about speaking in Arduino. And so JohnnyFive's fantastic. So this is kind of what that looks like. So in Fermata.js, it knows, what bytes it needs to write for writing to pins and reading from pins and making that request. So those 3 bytes there for both on and off is actually what's being sent over the USB cable to the Arduino, and the Fermata croc on that side is actually saying, oh, I got some bytes and I totally recognize them. So just for interesting trivia, the 237 is an analog message bit shifted with the pin address, so it knows what pin it needs to be doing it to. And the last 2 values are 255 for on in 2 different bit shifted formats for compatibility. Again, that's kind of more of the Mermaid level, so we're going to stay a bit above that. And to turn it off, 0, 0 kind of makes sense, right? And again, we've got our 237 because we're still using the same pin address. Okay, so that's kind of answered that question, but does Fermata do does it have the C bindings for the USB connection? Well, it actually doesn't, so we're kind of missing. We need another person to help out. So I actually asked Chris Williams, the author of Node Serial Port, if Node Serial Port was an animal, what would it be, in your opinion? And I got an answer back within about 20 minutes. Yeah, he says, holy crap, what a good question. Can I have a couple to think it over? And I was like, that's fine, I'm still trying to finish my slides. Well, he didn't get back to me. So I had to kind of choose something for him. So he has a really badly drawn electric eel. Because I think about a USB cable and I think about electrical, information going across it. So electrical eel made sense to me. So sorry, Chris, if this ends up being a thing that sticks. So this is kind of the layer in between, and obviously Node Serial Port runs on the computer, but this is kind of an ideal way of illustrating it. You instantiate a new copy of Serial Port, and you're running its write method. And do you recognize the code in between the parentheses? It's the bytes that Fermata.js wants to send. And for those who haven't used Node before, a buffer is just almost like a data type you can use in Node.js that allows you to create a specific memory allocation. So it's very zeros and ones. And so it's able to take that, and it's able to write that using some really good C binaries that it's connected to in order to write that through. So this is the message for Fermata that she's waiting for on the other side. And then we've got our light. that's all that was required. It's nothing, right? Like Hello World is such a simple thing. Like that wasn't complicated at all. Yeah, it kind of was, right? There's a lot of things going on underneath, and I think that when you're first starting with JavaScript hardware, you spend more time swearing at the Arduino, and so you're not very grateful by the time the light comes on because you're like, God, this is ridiculous. But this is actually what's happening underneath. This isn't a very useful illustration, though, and especially for those at the back. So let's have a look at it in more of a classic kind of sense. So again, we've got our laptop on the left. We have our Arduino on the right. And so JohnnyFive is your top layer. That's the easy breezy ocean layer where you're on the boat and you're just expressively using the API and everything's beautiful. And then Fermata.js underneath is taking the request and figuring out what it should be doing. So when you create a new LED on pin 13, it knows that's an output and it prepares the bytes for you with the value. And then you've got Node serial port that's actually doing the USB communication for you. So they're all kind of sandwiched together and very tightly integrated. And if you look in the JohnnyFive node modules directory, you'll actually see that. Then we're coming on up over to the top layer of the Arduino now. So this is the easy breezy layer, and this is the Fermata program that you can just upload. It comes free with your Arduino software. This is our crocodile, right? Our crocodile layer that can take those bytes and interpret them. And then she then utilizes the Arduino library, which is where you can look up the pins in the DDR and like which port is this pin in. And that's how you communicate with the AT-Mega chip, which can then send the current out to that pin to turn it on. It's like a gate system. So that's kind of how all that works. But that's a lot, right? But we got there, but it's a lot. And so what is the point of this? Well, what I'm trying to say is that abstraction is a really good thing. And I think a lot of the time we look down on each other for overusing jQuery and things like that. But I think it's good. This is the reason why we can write so expressively. And if you were to start from scratch trying to turn an LED on like that with JavaScript, it would take you forever. And the reason why Recordrien originally wrote JohnnyFive was because he got sick of setting up the same things over and over again. There's a lot of heavy lifting, as you saw, even just on the JavaScript level to get things going. And so I think that's really good. And I think that we should definitely be very supportive for people who are new to things to use abstraction, and even those who are looking to save time and have more elegant code to use abstraction. It kind of wraps developer empathy into this, right? You want to write a library that's good for people to use. You imagine other developers using it, and there's a reason why you wrote it in the first place. It's probably because you were trying to use something. And so my message to library authors is to delight your users. How can you create that LED.blink that seems so simple and so beautiful and so accessible on the top level? And how can you implement that for your users in your particular libraries? How can you make your library a delight to use? And secondly, for library users, for those that use jQuery, for those that are NPM installing all over the place, contributing to the billion and something that are downloaded every month, that is a scary number. If you're feeling up to it, if the boat's getting a little bit boring, maybe take a dive. Don't ignore your node modules directory with all your dependencies in it. Have a look at what's actually bubbling on under the surface. You might just find something that turns into an obsession for you. And it can be as simple as that, just ls node modules, and you go from there. It can be very exciting, and that's kind of a big reason why I learned so much about how hardware works. I wasn't just content with doing things. I wanted to know why that was happening. And you never know. If you jump down here, you might actually like it a bit more. And you might actually sort of start appreciating the open source community a little more too. And if you ever get down here, I feel like Substacks down here. I don't know if he's in the audience today, but if you get down here too, remember the people above. Try and occasionally stop speaking binary every once in a while and come back up here and start talking with the fish again. And hopefully in doing that, you may actually end up finding your own adventure, kind of like I did. And I think that that's definitely something worth pursuing. So thank you.
Thank you. I think that is the most interesting introduction to Arduino I have ever seen.
I'm trying to do that cool thing where I'm tweeting the link to my slides, but it's not happening. Matthias was smooth.
It was smooth. So I'm really happy because you just talked about like my favorite bit of JavaScript ever, which is the JohnnyFive library.
Awesome.
And I had that same experience the first time I used it. Was that, oh wow, this is so easy. It all makes sense. Things are blinking. Have you, like, how much have you used it? How did you get into this?
So I kind of got into Arduino back when Flash was still really cool. I still think it's cool. You know, it does like Canvas stuff now. And I had to, in order to kind of get the same sort of stuff going on, I had to use Flash with this software called Tinker Proxy, and then you had to collect the serial data with your own custom code on the Arduino and tunnel it through, and it was an absolute nightmare, but you felt amazing when you got it done. And so when Flash stopped being cool, I kind of put that down. And when JohnnyFive came about, I'd kind of been dabbling in Fermata and Node serial port and realized that this is just a way easier way to prototype. And a lot of people don't just prototype with JohnnyFive, they take it right through to the final product. So I think that's a real testament to how awesome it is to use.
So you showed us some projects there. The little, was it the purr bracelet?
Yeah.
Have you got that with you?
I don't. Oh, unfortunately, I don't. I had to decommission it to write a different tutorial. The good thing about having lots of microcontrollers is you can, you don't have to decommission projects. But at the time, I blew up a bunch of them, so I had to pull it apart.
I know that feeling.
But I do have like a similar Wi-Fi tutorial that takes sensor data and does something if it's at a certain point, and it's actually on my GitHub, so I'll try and remember to link to that on the hashtag.
Yeah, you should.
Yeah.
Because that's, obviously that's one of the things that happens when you start playing with this, is that you build something, and you realize that you have to take it all apart again.
It's heartbreaking, yeah.
Yeah, in order to build something else. Have you tried to get like your own boards printed and kind of making things a bit permanent, or?
I think that's what the next step is for me. So what you can do is you can take the minimal part of an Arduino that makes things work, you know, which is usually the chip with some, you know, with some voltage regulators, and you can just, if you really want to use JohnnyFive right through to production, which can work for Internet of Things devices, right? You know, using it as an API. It's not always battery efficient, but it works. You can then just upload the Arduino bootloader to it. And so you can basically do the exact same thing. You can treat it like it's an Arduino, even though technically it's like a home-baked circuit. So that's kind of what I want to get into next. Because I keep soldering these tiny little Arduinos, and I'm starting to lose my eyesight, so it'd be great to simplify the circuit.
It's really hard. From my experience, that's really hard.
Yeah.
Because I think, I mean, for the people in the audience, probably have heard of JavaScript before.
Gotcha,
But it might be the electronics bit that's kind of feels like a bit of a step up.
Totally.
Do you want to comment on that?
I think that's why I am so in love with JohnnyFive, is that it's funny when you blow up an LED, like it's hilarious, and you've probably bought a 100 pack of them anyway, they're really cheap. And so I think that it's extraordinarily enabling because, again, like if you're just a front-end developer, and not just, but if you're a front-end developer and that's all you've kind of done in your career, and other languages like Python, which is really good for hardware, you know, is a little scary to you, you just want to stick with one new thing at a time, right? The Arduino is the new thing, but the JavaScript is the familiar thing. I haven't seen any libraries out there in any other languages, and it's probably my favorite one implemented in JavaScript, like to get started, because that's the bit that you get to be all over. You're like, oh, I understand the structure of JavaScript and I understand callbacks, and so that's where I think it will really help people start getting into this stuff, because I think the failures in hardware are just as fun as the successes, as long as you don't electrocute yourself. So.
It's kind of hard with an Arduino, but
yeah, just buy an Arduino. They're like, you can get, because they're open source, you can get really cheap non-Arduino branded ones for like $15 these days. They're so cheap. So just pick one up and a USB cable and get at it.
Yeah, I had an experience last year with my non-programmer partner who got roped into a NodeBots workshop and kind of ended up with a really cool robot coming out of it, and like, oh yeah,
Totally.
It's just fun.
And then you go, one day is all that's required
Yeah.
to get up and running.
There's a question here about what about JavaScript on the Arduino itself for autonomous robots?
Mm-hmm. So there's some really good boards out there right now. There's the Arduino, and there's also the Tessel, and the Tessel 2 is coming out. The original Tessel just you write in JavaScript, and then it compiles it down to Lua and sends it over the wire. So it's like transpiling it secretly without you knowing. The new Tessel coming out is actually going to be running that on there.
Cool.
And you can also use the JohnnyFive library with Raspberry Pis and BeagleBones. So you can actually be running Node.js on those things. And there's actually, if you run JohnnyFive on the Raspberry Pi, it can access those GPIO pins too.
Yeah.
Which is super exciting because it's completely wireless. And so you can have those crazy webcam robots and people controlling them over the internet. And that's where the magic really happens, right?
Definitely.
Yeah.
And finally, like, what is it about cats and robots?
I don't know. I think just they like them. You know, you see them riding the Roombas.
Yeah.
And you'd think, you know, normally they're terrified of vacuum cleaners. I saw also there was a NodeBot workshop where you could make a kitty toy where I think it would just use a servo to swish like a feather on a stick around and the cat would chase it.
Yeah, so the robot I was talking about before was
Yeah.
basically that, but with a laser
Yeah, that's
kind of
awesome.
pointing around the room and the cats would chase it.
That's super sweet. There's really cats in your chip, I promise. There's totally those bellboy cats in there.
That sounds great. That was an awesome presentation.
Thank you so
much.
I appreciate it.